What is real number? Today our topic is real number. What is that? Real number, right? Wrong? Sir, we know the answer of the real number. What we know? I mean definition. What we know? All those numbers which can be represented on the number line is called real number. And also we can say that the collection of the irrational and irrational number is called real number, right? Wrong? So guys, I don't need to write that. Should I write that? Absolutely not, right? No need to discuss. So let me just leave the place here. I'm gonna leave the place for you, okay? And the second point, all the rational, you will just write like this way, okay? You will just copy like this way, right? You know point. All the rational and the irrational numbers are real numbers. Next point, you will just write by yourself, okay? All the integers are all the rational and irrational. Tell me. Numbers are real numbers. Or we can say all the rational numbers are the real number, all the irrational numbers are real number as well. Okay, but I cannot say all the rational numbers are real numbers. Can I say that? Should I start again? Should I start again? All this point. No, why should I start again? This question rises here. So many times we discuss. Why should we waste our time here now? All the integers are real numbers. All the integers are real. Tell me now. All the whole numbers are real number. Euler number? What did you say? Yeah? It's not about. Yesterday we talked about E, or day before yesterday perhaps. What was E? What is the value of the E in the approximate? Tell me the some decimal places. Stops. Continues. Sit down. Sit down. That's great. So guys, now all the rational and irrational numbers are the real number, right now? Tell me now. Now come on, try to understand now. Try to understand. No need to discuss all the integers are real numbers and all the odd numbers are real numbers. Not need to discuss. But now I just want to write all the things you will just write and all the things you will write. Okay, I'm gonna write the next point. Okay, a set of real numbers. This is a very important point, guys. A set of real numbers. A set of real numbers. When I said a set of real numbers, it means we are talking about, for example, I'll take root 2, I'll take root 3 plus 2, I will take 1 by 2, I'll take minus 1 by 5, dot. These are the set of real numbers. These are set of real numbers. It means the set of what? Set of rational number and set of irrational number. Now you can say that's rational number and as well as irrational number. When I say a set of real numbers, we can say this is a set of. This is not the way to write that. I made the very long middle bracket here. Why? So because I have written like this way. That's why. Okay. Can we move now? So our focus is today. Our focus is today completely real numbers. Completely real numbers. But because we talked so many things about the real number, so no need to discuss. No need to discuss. Now let me discuss something about the page number 79. Everybody, put your eyes there. Page number 79. By all the things we have to go through that, all the things we discussed already. Rational number 0.449. No, I don't want to discuss now. Bullshit things on the board. Page number 79. Put your eyes there. Properties of real numbers. Put your eyes there. Properties of real number. Put your eyes there. Once again. First addition. Now number 1. Closure property. Sum of the two real numbers is always. So no need to discuss, no need to write on the board. Directly we can understand. One more time. The sum of the two real numbers is always real number. Difference of two real numbers is always real number. The product of two real numbers is always real number. And the quotient of two rational number real numbers is always real number. It is called closure property. One more time. Arey bhai, just you tell me na yaar. You tell me. Yeah, you tell me na yaar. For example, if I'll take the 2, if I'll take the root 5. Okay. Now I'll put the value of the root 5, approximate value. So real number. Result also will get the real number, na yaar. And for example, I'll take 4 multiply 5. 5 multiply 4. Sir, 5 is the real number and 4 is the real number. because I can represent along the number line. Right? 5 can be represented on the number line. That's why I can say it is a real number, right? Wrong? So 5 is a real number and 4 is a real number, right? So 5 into 4, what will you get, guys?
20.
What will you get? 20. Sir, real number, real number. The product is also real number. Sir, 9 minus root 16. Sir, 9 minus, what will you get, guys? 4. What will you get? What will you get, guys? 5. Sir, real number, result is also? Difference is also real number. That is called closure property. I hope you understood that. Next. Go fast. Listen, nice. Guys, there are two properties of the commutative law. The commutative law of addition and commutative law of multiplication. One more time. For example, I have the two real numbers A and the B. Commutative law also tries to satisfy the real numbers as well. I have two real numbers A and the B. So I can say that A plus B equal to B plus. Can I do this? Tell me now, A. So A plus B equal to B plus. What does it mean? For example, 2 plus 5 equal to 5 plus 2. Right, wrong? And this is called commutative law of addition of real numbers. Commutative law of addition, and if I'll take A and the B, so I can say that A into B equal to B into A. Can I do this? It is called commutative law of multiplication. 2 into 5 equal to 5 into. Your answer is same, na? That's why you can say that it follows commutative law of multiplication. Why it seems like that you don't revise anything. It's possible. 2 into 5 equal to 5 into 2. What do you call now? Commutative law of multiplication. It follows. Next. Associative. By again the same thing. By associative law it follows the two ways. Associative law of addition, associative law of multiplication. One more time. Associative law of one more time. Associative law of listen. For example, someone write 5 plus 3 plus 4. I'll take the bracket here. So I can say that 5 plus 3 plus 4. I can take the bracket here, right? But now after adding both this one, you will get the same answer. You will get the same. You will get the LHS. Same thing. You will get the RHS, right? And 5 plus 3, what happens, right? What will you get, guys? 12. Just try the board mass now. The rule of the board mass. The 5 plus 3 plus 4. What will you get? 7. What will you get, guys? So I can say associative law of addition and multiplication follows the same way. For example, it is A, it is B, it is C, right? Now, come on. Second example. So, for example, 5 multiply 4 multiply 3. I can take the bracket here. And after that, I'll take the bracket here. 5 multiply 4 multiply 3. And don't ask me the nonsense question. Sir, if I take the 4 terms, what will happen? Don't ask me the nonsense question now. When I say don't ask the question, ask the question. Let's go. Yeah, okay, let's go.
If I remove the bracket from there in addition.
Yeah, addition.
If I remove the bracket.
Okay, then what will happen? Huh? What will happen? Do you know that some rules are there inside the soldier campus? Do you know that? Well, sir, for example, you have to wear the uniform in the school. No need to wear the uniform in the home when you go to sleep in the bed. Do you wear any uniform when you go to sleep to the bed? Do you sleep? Do you? Right now, what we're talking about, associative law of addition. So it means it says that it is defined. Some criteria is there, some boundaries are there. Everything. When do we say it is a mathematical rule? When we say that it is a concept, of course it's a concept, but some concept given by some person, and he made some rule. How should you do that? How should you operate that? One more time. By mathematics, everything in the mathematics has a concept. What is studying the mathematics? So there is a concept. What is studying the mathematics? There is a concept. But you know this concept given by a man, and man made a rule. Man made a rule. How should you operate this time? He says that no, you cannot remove the bracket there. If the bracket is there, if I take the bracket, associative laws defines that you have to take the bracket, and this defines associative law. If you remove the bracket, then what it says, I don't know. What it want to say, I don't know.
Is there A plus B?
Yeah.
And the bracket plus C.
Yeah.
And equal to A plus and the bracket B minus C.
Minus C?
plus C. If I write
A plus B plus C, right? Like this way? Right? Okay, after that, A plus B plus C, like this way? What's your question?
if I write like this, B plus under bracket C plus A. B sir.
Huh?
Must be under bracket
B
plus
plus
under bracket bracket.
bracket
In this sense.
here?
No sir. Under bracket A plus.
Come on the board. Come here. Come here. Ask you a good question. Asking the question, but not the good way. I love the asking somebody asking the question. I love that. But problem is that I'm asking the 2 plus 2 is equal to how much? I have the problem. A was the variable. B is working as the variable as well. A was the variable. B is working as the variable as well. So why you are replacing that? Why you are just putting the B in the first place? The B was in the second place. Why putting in the first place? Even we can choose that, no problem at all. Yeah. Yeah, of course we can choose that, no problem. But problem is there about the beautiful definition, the beautiful decoration. Yeah, of course that's true.
Irrational.
Did I say that wrong? Yeah, addition, of course it is true, no problem at all. It is true. After adding, we can say, but why breaking why doing the breaking? Yeah, why just breaking the rule now?
Is there anything except rational and irrational? In that we are studying rational and irrational, and this both condition applied. It is correct.
What is the next associative law of addition? You understood that, and multiplication also is understood that. Right at the bracket here. No need to discuss. There's a bullshit type of basic things. I discussed already. No need to discuss. Let's go. Next, additions of an identity element. Read out. Sir, 0 is called additive identity case clause. One more time. One more time. 0 is called additive identity. 1 is called a multiplicative identity. One more time. For all real numbers. One more time. What does it mean that? Sir, 5 plus 0, no changes. 0 plus 5, no changes. So if I can take minus, it will be minus. If I take the minus, it will be minus, no changes. It is adding 0 to any real numbers, adding 0 to any real numbers, no changes at all. When there is no changes, that's why 0 is called. Keep in mind, always, it never changes. If somebody asks you, what is the additive identity in the real number, always is at 0, case closed. And what is the multiplicative identity in the real number? In the case closed. One more time. 0 is called additive identity. Additive. Now you can see the additive. The word is add. It means adding. You can see there now. Plus. We are adding. We are doing the plus here. 0 is called additive identity, and 1 is called. One more time. 1 is called. 0 is called additive identity, and 1 is called. But yeah, 5 multiply 1. What will you get? 6 minus 6 multiply 1. What will you get? A multiply 1. What will you get? B multiply 1. What will you get? It means A is the real number, B is the real number, minus 6 is the real number, 5 is the real number. So any real number multiply with 1, no changes. The same number will be copied. Same number will be right or wrong? Same number will be. So that's why I can say that after adding 0 to any number, to any real number, then the result never changes. Result will be as it is. Result will be right or wrong? Result will be as it is. Any problem? Tell me now. So I can say that adding 0 to any real number, the result will not be changed. That's why I can say that 0 is called additive identity, no problem at all. The existence of the additive identity element. I can say that 0 is the. Let's go. Is existence of inverse element. Let's go.
If Real number, the real is 0. Minus x plus 5.
अरे यार yeah, you'll just copy. Yeah.
6 by 0.
Start up. Start up. Any number by 0, what happens? Undefined, sit down now. When something is undefined, I cannot define. When something is undefined, I cannot. When something is undefined, I cannot define. Understood the point? Bhai, you are saying the 6 by 0 na yaar. What is 6 by 0? But don't tell me multiply by 1, multiply 2, multiply 3. I don't care multiply, what you multiply. My question is there 6 by 0, what happens? When something is undefined, I cannot define anything. Now shut your mouth. What did you say? It was a very fantastic question you're talking about. But asking like a child, nursery child, bullshit you comes from my mouth. Asking behaving like a nursery child student. Nursery child student, B plus A equal to A plus B, and A plus B equal to B plus A. So why it happens? I don't know what happens. I don't know why it happens. 2 plus 3 equal to 3 plus 2. So why it happens? Why they are equal to each other? So 2 plus 3 is equal to 3 plus 2. So they are equal to each other? Yeah, of course I don't know 2 plus 3 equal to 3 plus 2. I don't know. Let me prove now. Let me just go to the mathematics. I want to do mathematical. Just give me some mathematical proof now. Just give me the higher mathematics to prove 2 plus 3 equal to 3 plus 2. I don't know that. No, how can I prove that 2 plus 3 equal to 3 plus 2 by the higher mathematics? Just I will say 2 plus 3 equal to 5 and 3 plus 2 equal to 5. Case for simple one line statement, not one line, half line statement. What is there? 2 plus 3 equal to 5 and 5 plus 3 equal to 2 plus 3 equal to 5 and 3 plus 2 equal to 5. Both are equal. Case close, simple. Why we are discussing? Why waste your time? Just if you study everything in the class 2 now, what will you study in the class 12? But this is a good question. I'm just kidding now. I love the question. Let's go. Inverse. Why inverse is very simple. Inverse means just opposite. One more time. Inverse means? One more time. Not the reciprocal. Reciprocal is different. When I say the word inverse, it's another. With the word inverse, for example, I have 5. The inverse element of 5 equal to minus 5. The result is always should be 0. I think we studied one of the name of this one. Huh? Thank you, Tuba. You're actually helping me now. But this is called additive inverse as well. Additive inverse by adding 1. When we add two different things, whatever the element is there, adding 2 different things and getting 0, it means both are called additive inverse to each other. For example, I have minus 6, the inverse element of the minus 6. 6. The result will be 0. I hope you know that. Read out the definition now. What I'm saying now, I'm just telling you now. A I have and a minus A, right? A I have and a minus A. The sum of this one, sir, A plus minus A. What do you get, guys? A minus A. What do you get? 0. By result, we are getting 0. So I can say this is the inverse of the A. Minus A is the inverse element of A. Can I say that? And also I can say that A is the inverse element of my vice versa. What is that? Vice versa. Vice versa means this is true for this and this is true for this. This is a true for this and this is a true for this. That is called vice versa. It goes like when we show in the mathematics vice versa, we have to show like this. This is called vice versa. This goes here and this comes here. That is called vice versa. I hope to show that. Again, a point. For example, 5 plus 3 equal to 3 plus 5 equal to add. So I can say that if you just write like this like a child, then you have to show like this. You have to show like this. It is a way to show that. You get a point. But actually, we should not solve the question like this. We solve the question like this way. That's why we need to write like this way. What's going on here? What's going on? We go like this. Okay. Now, understood the inverse element? Read out that one more time. If A is a real number, then there exists a real number minus A.
plus minus is 0 minus give it a rational.
Huh? What I said about the zero, the definition, do you know anything about the zero? Stand up now. Very good question you're asking, but I want to check you now. Tell me what I said about the zero.
Neither positive nor negative.
So it means I cannot make it positive or negative.
It's rational.
It's a real number, yaar. Yeah, it's a real number. Zero is a real number. So it must be written. It must have written here, except zero, but not written. No problem at all. We can ignore. We can ignore now. No problem. He's asking the good question here. Now what about the zero? But zero. Right? He's asking what about zero, yaar? What is the universal element of zero? By nothing. I cannot say it is minus zero because minus zero does not exist in the mathematics. When I say the zero, it means nothing. I cannot say negative zero and positive zero. It is neither positive nor negative.
So, sir, another question. Like same question. 6 by 0 means it is undefined. Inverse of this undefined is minus undefined.
He's saying that so 6 by 0, it will be the minus 6 by 0, I think. And result will be 0, I think. You are saying that?
It is undefined. It is minus undefined. Undefined. 0.
So why don't you say it's a positive undefined? Say it positive undefined?
Yeah.
A negative undefined. Wow. Yeah. Yeah, of course. When something is undefined, right, it does not exist in the mathematics. There's no existence of 6 by 0 in the mathematics. When there's no existence, how can I say it is positive or negative? When there's no existence of there's not existence till 12. After that, I don't know because I studied graduation mathematics. I don't know about it. Right now I'm talking about. I'm Kamil. Don't put your head down. Don't put your head down. What I'm saying, why something is undefined, how can you tag it positive and negative? When something is undefined, how can you say it is positive or negative?
Real number, outside of real number, you write minus undefined, minus.
I did not write the minus undefined. I just write the minus infinity. It is not undefined. It is minus infinity. And minus infinity, the symbol, and that exists. And there is the operations of things are there in the mathematics. You will study class 11 and 12. He's asking that, sir, when minus 1, minus 2, minus 3, dot, 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 minus infinite. He's asking that. He's talking about, you're talking about this one, huh? And 1, 2, 3, dot, 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 plus infinite. So he's asking that, why did you write the plus infinite, minus infinite? He's asking that when he's undefined, why did you write the minus one? But I did not say that. It is symbol. It is given the big number given by a symbol, and that symbol exists in the mathematics. And there are some operational things that you will study in the limit chapter, LIMIT limit chapter, in the integration. So you will study there. I cannot teach you now. Have patience now. So what I'm talking about, Afan, listen now, listen. क्यों इतना सजा दे रहे हो भाई? क्यों मुझे मजबूर कर रहे हो? जिंदाओं पर जिंदगी से दूर, या जिंदाओं पर जिंदगी से दूर. अब क्या बताऊं मैं किस कदर मजबूर हूं. छोटी सी गलती की इतनी सजा मिली है मुझे, आखिर कैसे कह दूं कि बेकसूर हूं. Let's go now. What I'm talking now. Listen. I'm just talking you the 6 by 0. 6 by 0. But it does not exist. When it does not exist, I cannot say positive and negative. I cannot say that. Let's go. Don't waste your time. Multiplication. But I just talked now. If the A and B are the real numbers, the A plus B will be the real number, and A into B will be the real number. Read out. Three number is very easy. 4 number we're going to discuss. There is a symbol we're going to discuss today.
Inverted L.
Huh?
Inverted L.
You are getting excited? Sir, ulta hai, sir. What is so? It shouldn't be.
Inverted L.
But
No.
it is in multiplication. A multiplied with B under bracket plus C.
Which number point you are talking about?
Third number.
You are it down?
A multiplied B under bracket and after plus C is equal to A multiplied under bracket B plus C.
Yeah.
If I separate B outside the bracket,
Huh.
under bracket C multiplied A, the answer
Yeah, of course, yeah. Okay, if you are doing that, if you are saying that I wanna write like this way, you wanna write like this way, and you are saying that it is correct. You are saying it is correct, now, and it will be written like B multiply A multiply C. I think you are saying it is correct, or something else you have. No, if you some other talk, if you can talk, no problem. Some other you are saying this.
in this one, A and C is after bracket. It is not in the bracket. A and C. I want to separate B.
So I separated. Yeah.
So this one is correct.
Sure, why it is not correct? Of course. If you are just writing like this way, why you have the problem? Why do you have the problem to write like it is not beautiful, it is more beautiful. You can do this. Why don't you do that?
So, but what examples?
Come here on the board, write the example. One example. Okay, just tell me something. What kind of example should I take?
5 into 7. 5 into 7.
Okay. Yeah.
5 into 5.
5 into 7 into root 3. Okay. Take the bracket where? 7 under 3. 7 under root 3. Here. Yeah. Okay. So equal to, yeah. Sure. Okay. Under root 3 outside. Multiply. Under bracket. 7 multiply 5. Okay. Okay. Can we do this or not? You are asking that. 100% we can do that. But the problem is here. You miss the order. You disorder the thing. You disorder the order. One more time. But of course they are equal. They are equal. That's why it is called commutative law of multiplication. Associative law of multiplication. Yeah, but of course both are equal. When they are equal, it must have the specific name. And what is the name of this law? Associative law of multiplication. Associative law of. But why you are breaking? Why ordering disorder the order? Yeah, of course, 100%. Values will be same. Multiplying all this one, you will get the same value.
Yes, two cases will be same. But after that, will write one more equal to again. And B will be
What's let me actually you're confused. Listen. What's I will take 5 multiply 4 multiply 3. Okay, I'll take the bracket here. And now you have written this number first. I'm gonna write this number first. Okay. And after that you have written 7, second number. Okay, you're writing second number. Okay. And after that you'll write 5, right? Okay. 5 as it is. 4 3 jump. 12. 12 5 jump. 6 3. 3 4 5 jump. 23 jump.
separate the 4. That's it.
Where should I put the 4? 4 outside. 3 here. Okay. 4 3 5 jump.
So it's equal to here. Same thing.
Come on, sir. Sir, come here. माने जलेबी तरह गोल हो जाओगे तुम. जलेबी मांग रही है रे. Keep watching. Keep watching. I love discussion.
Identity means the same.
Identity comes from the word identification. When the word identification, it means there are some identification. For example, do you have the identity card, like Aadhaar card, like PAN card? No problem. You will have later. Okay. So it means Aadhaar card is working as an identity. When the word is saying identity here, there are some identification. What is identification? When the zero will be there, adding to any number, the number will not be changed. That is called identity. There is some pehchan. There is some identification. Ray, try this. What happened?
It should be right there.
It should be done like this way. It should be. Why are you doing this? Of course, it should be. All are equal. No problem at all. But don't do this. Next.
But it belongs to one is equal to one equal
Mathematician was very clever. They were very clever. Tell me how. What up? What? What up? Go. Come first. When the word is there, clever. When the word is there, opposite A, inverted A. Understand directly. By this is called for all. For what does it mean that? What is the? Try to understand that. What is the? By it means this symbol known as. For example, anybody knows the name of the symbol? Huh? Anybody knows this symbol? Omega. This is called omega. Okay. We're gonna study very soon. Omega. Very very beautiful. The questions are made from this one, guys. So similarly, I can say that this is called for all. This is called for all. Sir, what does it mean? Read out that one concept.
What is the identity element for all males? It is for all. And belongs to
Now, as I told you in the earlier classes, or we discussed earlier classes, that one is called a multiplicative identity. But right now, it is written. It is written. One is the identity element for all real numbers. What does it mean that? It means multiplying any number by one, you will get always the same number. Multiplying one with any number, you will get always the real number. You will get always. Sir, it is written like this way. What does the mean of this one? For example, written like this way, and written like this way, and belongs to like this way. Perhaps it is written like this way. That is right. It means, how will you read out this one? For all values of A belongs to the real number. For all values of A belongs to the real number. One more time. For all values of A belongs to the real number. It means what is A? A have to be defined. What is A? A is a natural number, or the odd number, or the even number, or the integers. What are there? Bhai, the question is saying that for all values of A belongs to the real number. It means A is the real number. One more time. And here is the written opposite inverted A, and saying that all, it is not saying that only the tag the real number root 2, the tag the real number 1 by 2. It is saying no. It is saying that tag any of the real number. One more time. It says that any of the real number, whatever comes to mind. That's why it is saying that value of the A belongs to real number. It says that for all values of A. One more time. And what is A? A belongs to? So I can take 1, I can take 2, I can take root 2, I can take 0, I can take minus 3 by 5, I can take root 3 by root 5. I can take anything. And what it says, the concept says that A multiply 1 or 1 multiply A will be always. What does it mean that? It means, for example, 2 multiply 1, you will get 2. The a, here is the 2. What is the value of the a? Is 2. You will get 2. So for example, 3 multiply 1 is equal to, always you will get 3. Root 2 multiply 1, you will get root 2. It means saying that all the values of the a multiply with the 1, it never changes. The a will be the answer. I hope you'll show that. So it says when the word is saying for all values, for today we have completed. Only you have to just, don't need to do anything, just revise and try to solve previous questions. Yeah, no more questions today. It's done today. Whose book is that? Understood the point? Case closed.